Okay, so everyone has a different sort of idea of what the important concepts are in calculus. A lot of people think the introduction of something called limits is really the key idea. And that definitely is a key idea in my mind in calculus. But I also think a key idea to take away from learning calculus is thinking about how to approach problems that you don't know how to do using ideas that you do know. And it's a tricky example because you already do know how to calculate the area of that triangle as we did in the last. And what's the idea for calculating the area of a triangle like this?
You can make it into a square.
How?
If you like reflect it over this line, you get a square.
Okay.
And then we know how to find the area of squares,
which is based on side.
and it's half of that.
Yeah, and that's the idea we're going to use here to find a different way to find the area of this triangle. Is we're going to chop it up into rectangles. Okay, and you see that the rectangles don't quite fit. There I'm using a smaller number of rectangles. Oh, you know what? I'm doing this slightly backwards. I'm going to reflect everything over this way. Sorry about that. You'll see why I'm doing that in just a second. But when I put those on top, you see it doesn't quite fit. So the area of this is going to be bigger or smaller?
Well, it's going to be probably
Smaller.
less because you're excluding these triangles here.
Yeah. How about the area of this one where I've chopped it up into a little bit more finer
It's
rectangles?
still going to be a bit smaller.
Yeah, but just a tiny bit.
Okay. And what about this one?
It's
It's
gonna
chopped
be
up into...
even closer.
Yeah, it's
Okay.
going to be about that area.
Alright, so just from that visual example, what do you think my idea is going to be here for finding the area of this?
So we can find the area of this and this and this.
Or you could like chop it up into squares and see how many squares fit inside this.
Okay, yeah.
They have to be infinitesimally small.
Yeah, does that bother you?
Well, we can't really do it then.
It'll be like points. How many points fit in a triangle?
Yeah, well what's the answer to that question?
Infinitely many.
Infinitely many, yeah. So you're on the right track. I'm going to not chop it up into squares, but I'm going to chop it up into rectangles.
Oh.
And because I know the areas of rectangles as well.
Yeah.
And so I have a shape like this. And I'm going to just chop this up, like let me use an example where I chop it up into 4 bits. And at the height of every one of these bits, I'm going to draw a rectangle over, like that. So how big is my first rectangle?
It's just, no, your first rectangle is just a line.
Yeah, so what's its area?
0.
0. And if this was 1 over, and I've chopped it up into 4 pieces, this comes over 1/4. How high up does it go?
I think it goes up 1/4.
1/4, because this triangle, for every 1 it goes over, it goes up 1. So for every 1/4 it goes over, it goes up 1/4.
So that area would be 1/16.
Okay, yeah, so this rectangle here happens to be what shape?
It's a square.
It's a square. And you can sort of see that here in this one, even though I haven't chopped this one up into 4, it's 1, 2, 3, 4, 5, 6. But you can still see that part. That first one seems to be a square. And then, so this one goes, so this is 1/16. This one is 1/4 wide. How tall is it here?
Well, it's 1/2 tall.
It's 1/2 tall. So what's its area?
So it's 1/8.
Okay. And how about this
And
one?
then 1/4, because that's a fourth, and that's, wait,
3/4.
is it 3/4 tall?
Okay.
Because you're excluding a little bit.
Yeah.
Yeah.
So it's 1/4 wide, and that's 3/4 tall.
So it's going to be 3/16.
3/16. And if instead of writing 1/8, I write this in terms of sixteenths,
It'll
what would I
be
get?
2/16.
2/16.
Do you see a pattern?
Yeah,
Yeah,
1/16,
it's going
2/16, 3/16.
What about the first one?
0/16.
Okay. So I have a very interesting pattern here. If my width is 1/n, for any number here, the n is 4, I seem to get 1 over n squared times 0 plus 1 plus 2 plus, what's the last number going to be in terms of
It'll be n minus 1.
Do you see that?
Yeah.
N minus 1. Now we could go through and show this all, that this is in fact what happens, not just with 4, but with 6, and with however many this is, and with however many this
Wow,
is.
that's a lot.
Yeah, but what we thought was happening was we were getting closer and closer and closer to the area, right?
Shouldn't it be 0 plus 1 plus 2 plus dot dot dot?
Oh,
Plus,
yeah, you're right. I forgot my dot dot dots. Thank you. Okay. And so now we just have to know how to add up 0 plus 1 plus 2 plus up to n minus 1. All right, so let's see if we can figure that out.
Okay.